Raising a product to a power. On the upper right, you see that we have AB in parentheses raised to the n power, and this equals A to the n, B to the n. Each one of our exponents inside the parentheses is an understood 1, because when you see A by itself, even though you don't see an exponent, there is an understood 1 there. Our B also has an understood 1. So we keep the base A and we multiply 1 times n and get A to the n. We keep the base B and multiply 1 times n and we get B to the n. On the left, I have an example using numbers. And here in parentheses, I have 3x squared y to the negative 4 z. And then that's raised to the third power. Our 3 has an understood exponent of 1, and so does our z. So we keep our bases inside, and we're going to multiply each inside exponent by the outside one. So I'm going to keep the base 3, and I'm going to multiply 1 times 3 and get 3. I keep the base x and multiply 2 times 3, which gives us 6. I keep the y and multiply negative 4 times 3, which is negative 12. Keep the z and say 1 times 3, which is 3. And this is our answer, but we don't want to leave any exponent negative. So if you think of this like a fraction, and any whole things will always have an understood denominator of 1, in order to make our y have a positive exponent, if we take this and bring it down to the bottom, this is the same as writing the reciprocal. And also we want to go ahead and raise 3 to the third power. So 3 to the third power is 27, and we have x to the 6, and we keep our z to the third, and then our y to the negative 12, our y comes to the bottom, and our exponent becomes positive 12. So here, when you have a product raised to a power, keep the bases inside the parentheses and multiply each inside exponent by the exponent outside.